Hi, so this is Serving Up Physics. My name is Zach Myers, and I will be briefly discussing what is tennis and how is physics applied in the sport of tennis. So first we need to discuss what is tennis. Tennis right here, as you can see, is this picture. This is the layout of the court.
Serving Up Physics.
So dimensions wise, it is around 78 feet discussing in length. What is tennis and how is physics applied in the sport of tennis?
So it's a
first we need to
rectangle kind of
discuss
shape.
what is tennis.
We'll get to the lines here in a second. And scoring.
Hi, so this is Serving Up Physics.
Points.
My name is Zach Myers, and
so
I will
when
be
you score
briefly
a point
discussing
in the first
what
game,
is tennis
you have
and how is
15.
physics applied.
Your
in
next
the sport
point
of
goes
tennis.
up to 30.
So first we
then
need to
45,
discuss what is tennis,
and then you win the game on the next win. And so in
so
tennis,
this is Serving
you have to
Up
win sets.
Physics. My name is
In
Zach
a set,
Myers.
there are 6 games needed to
what is
have
tennis
a set
and
won.
how is physics applied
And in most
in the
tournaments
sport of
and
tennis.
big
So
matches in the
discuss
professional
what is
sport,
tennis.
you need to win 2 or 3 sets. So it's a pretty long game.
So this is Serving Up Physics.
So with these lines here, if you're looking at this picture right here on the slide,
what is tennis?
The outer border is the whole court, and that is used for doubles.
We need to discuss what
Singles, one-on-one, are going to use that long line,
so this is Serving
not
Up
entirely on the outside border.
Myers.
And so you have these squares in the middle of the court. Those are for serving. So if you're serving, you'll notice on each side of the baseline, there's a little indentation in the middle. You have to stand on one side of that and serve diagonally into the square that's across the net. So if I'm serving on the bottom right of the court, I have to serve in that top left square, that little quadrant. And that is how you start the serve, and that's how you start the rally. So in singles and doubles, there's not much difference. The main goal is just rallying back and forth across the net, right here in the middle. And whoever hits it out of bounds or misses it, the person will win the point. And yes, you serve to start the point, and you just go from there.
This is Serving Up
that is
Physics.
the basis of what is
Zach
tennis.
Myers, and I will be briefly discussing
physics
what is tennis
concept that I'd like to discuss is trigonometry. I find trigonometry to be one of the most important aspects of this game. So the Pythagorean theorem states how you find a side of a right triangle is a squared
and I will be briefly discussing what is tennis and how we know the court's dimensions in the sport.
So the length I said was 78 feet, and the width was 27 feet. That is including doubles. So imagine we're playing doubles whenever I speak of these lengths.
Physics. My name is Zach Myers. And I will be briefly
discussing
there are areas
where
angles
and
are
how
used
is
physics applied
the most
in the sport of tennis.
Serving is critical.
First we need to discuss
this image used from Jane Palace's study shows a great example. It uses a 9 height
physics. My name is
from
Zach
the person.
Myers.
That includes the person's height
what is tennis
and not the ball.
Physics applied
see,
in the sport of tennis.
Line above it is going, I think, about 3 extra feet. So you got to include, because when you serve, most people serve overhand, so that adds another height.
My name is Zach Myers.
Starting height of your body. And so to the square, imagining if you hit exactly on the end of the square on the serve, it is 60 feet. You also have to know you have to clear the net in the middle. So here we can use the Pythagorean theorem to find the distance needed to serve it in the square as a maximum distance. And also clear the net. Also, and not just serves, but you can see that you can use degrees in finding how much distance is required to run in order to get the ball. Let's say someone rallies the point over to me, and I'm about to hit it. I'm standing directly in the middle of the court on the baseline, and I'm looking at the other side. I hit it at 5 degrees angle.
My name is Zach Myers.
We can figure out how much distance my opponent is going to have to travel right or left to get to my shot.
So first
imagining he is on the baseline as well. So the court, again, 78 feet. I open up the angle at 5 degrees. So we know the angle and we know the length. So we're trying to find that base on the right triangle, and that will be the distance needed. And to do that, we use the tangent formula, and that gives us at 5 degrees, We can calculate it, and he will need to travel around 6.8 feet.
My name is Zach Myers.
We can do the same thing with 10 degrees, which is a much wider angle, and he has to travel 13.8 feet. So the thing is, with tennis, the greater angle of a shot is going to require the more greater distance needed for your opponent to travel in order to get the ball.
And I will be briefly discussing
it's important to know the court's dimensions and also the angles
in the sport of tennis.
Going into another
first, we need to discuss what is tennis.
Here is a superb picture to clarify this.
See,
you want to kind of hit the corners as a strategy in tennis to get the guy to run a lot. Wear him out, tire him, so the angles are very important. But whenever you don't have the ball, positioning yourself is critical in tennis. This guy that's about to hit it on the far side in the picture is on the corner, right corner.
My name is Zach Myers.
So you don't want to be standing here on this bottom left corner when he has all that room over here on the right side of your area to hit. You want to be right there in the middle of his angles. The maximum angles he can hit it inside the court and get it in. You want to be right there in the middle so you can cover left and cover right. So it's kind of important to understanding his shot and his angles.
So first we need to discuss
trigonometry is very critical in your accuracy and your hitting and calculating how much distance is needed and just trying to wear out your opponent.
My name is Zach Myers. And I will be briefly discussing
velocity and acceleration. Again, this is very powerful
in the sport of
going back to serve.
So first, we need to
this person is serving overhand. You can also serve underhand if you'd like, but in regards to the professional game,
my name is Zach Myers,
are required to serve overhand.
Discussing
in this picture,
tennis and how
the man is serving overhand, and
so
let's say
we need to discuss what is tennis.
150 miles per hour. That's doable. That is very high up there in the tennis game.
My name is Zach Myers, and I will be
briefly discussing if you are hitting 150 miles per hour. Imagine standing on the other side of the net, trying to retrieve that ball and return it. That sounds awful. That is very fast. So in tennis, if you can serve that hard and get it in the square for a point, most of the time you're going to win the point because that is hard to return. So this is a major factor. But what determines how much power and force, or what determines how fast the serve is?
My name
generating
is Zach Myers,
a greater amount of force can help us generate that power.
Tennis and how
so diving into this picture, it's important to note how he's serving. You go 1 and 2 pictures, he's throwing the ball up. Notice in 3, this is the most important factor. He's bending his knees and coiling up into a little spring. This is going to generate that elastic potential energy to where he can explode off the ground using the forces on the ground to build himself up and spring upward and to reach that tennis ball and come down.
And I will be briefly discussing
that is where our force is generated mostly. Now, Tom Colligan in his studies, he tells us and goes into the percentages of what body parts are needed and how much they impact the force in our serve. In this study, almost over half of our trunk is responsible for the power. So our legs, our thighs, and our lower body explodes. That is where most of our power comes from. You also have the arms, the rotational motion of our shoulders, and the abs. But the trunk and coiling up, the bending of the knees, that is where one is going to find where you generate the most force, having that good form.
This is
the momentum and impulse now.
My name is Zach Myers.
Now that we have gone over velocity and acceleration, we can dive a little bit further into the impact of when you serve and hit that ball and deliver the impulse.
First, we need to discuss what is tennis.
Momentum can be found by multiplying the mass versus the velocity. While impulse, you can multiply the force by the change in time. So when you're tossing a ball upwards, the ball is going to have a momentum. Once you make contact on that serve or any other hit, it's going to be conserved. You're going to change the momentum.
Zach Myers,
and you're going to deliver an impulse.
What is tennis and how is physics
I think the most
in the sport of tennis? So
Next
first, we need to discuss what is tennis.
What kind of determines momentum and impulse? What determines how hard and how fast
this is serving
the
up
impulse
physics.
momentum are.
My name is Zach
Elasticity
Myers, and I will be briefly discussing
being able to stretch
tennis and how is
the
physics
recoil
applied
and come back to your original
tennis.
state.
So first, we need
so
to
where you find
discuss
elasticity in tennis is with the string tension, how the rackets are made.
So this
and
is serving
how
up
tight
physics.
they are.
My name is Zach
So a racket
Myers,
is you hold
and
it.
I will be briefly
you hold a handle,
what
and
is
as it goes
tennis
upward,
and how
it creates
is
an oval shape.
in the
And there's
sport
strings
of
that are
tennis.
going perpendicular.
So first, we need to discuss what is
kind of
tennis.
creating squares. So, and they vary with every racket. So not every racket is going to have the same tension.
Myers,
You're going to have very tight tension with less
tennis and how
elasticity.
You're
going to have very low tension, which is going to be able to expand greater. This is important because you can be able to hit the ball, control the ball. The elasticity of the string's tension
My name is
Zach critical.
Myers.
If I have a higher tension on my string, I'm going to have a lower time in controlling that ball and determining the spin. It's going to bounce off of it faster and quicker, less spin. While on the other hand, you have lower tension, there's greater time in reaction, and you can be able to control the motion of the ball.
So first, we need
going
to
into
discuss
kind of
what is tennis.
Picture the top spin. The ball is spinning forward.
So this is serving up
so
physics.
Gravity is pulling it down,
Zach Myers,
and the ball is spinning
and I will be briefly
forward.
discussing
that kind of helps gravity.
Tennis and
That's why you see a sharp drop in the ball here on the other side of the net.
So first we need to discuss what is tennis.
It's going the other way. It's kind of acting congruently with
this is
air drag
physics.
So that is why it's
Zach Myers
going in that steady pace, and it's not dropping as
tennis and
while the flat shot it's just naturally going in a type of motion, and gravity is going to act on it, and it's just going to drop and have a normal bounce. And air drag are very important.
This is serving up
when trying
physics.
to work with the velocity of the ball and the rotational motion, and also it kind of goes along with their angles,
and how
as we mentioned before.
Applied in the
so
sport
there's
of
a
tennis.
skydiving example
first we need to
where we can see how
air
drag and friction to the game of tennis.
So
in this picture, we have a man jumping out of a parachute.
My name is Zach Myers.
It's an interactive little picture.
What is tennis and
so
how
we can see the formula.
Applied
so
in the
as it
sport
restarts without the parachute, he's going to jump out of this plane and have a acceleration with gravity. So 10 meters per second as he starts. But as he's falling without the parachute, air drag is going up, 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 up until it meets gravity's force. Then they bounce.
In the sport of
and so he has a terminal velocity. He's not accelerating anymore, and he just has this constant velocity. However, then he opens the parachute and air drag increases.
My name is Zach Myers.
And so then he slows down because the air drag is greater than the force of the gravity.
How is physics
so in tennis,
in the sport of tennis?
So if you hit the ball,
first we need to discuss
and
what is tennis.
Air drag is equal to the
so this is
gravity
physics.
It's going to remain constant in acceleration, but if air drag is greater, then the ball is going to slow down. Air drag again is opposite
in the sport of tennis.
Or acting in the opposite direction of the motion of the tennis ball. So it is going to gradually slow it down. And that is the key concept here with those two forces and how they work.
My name is Zach Myers. And I will be
now we've reached our conclusion.
What is tennis
these
and
four
how is physics applied in the
physics I find are the most important.
First, we need to discuss what is tennis.
Again, we went over trigonometry and our angles and how we can figure out the distances needed to reach the ball, or
and I will be briefly discussing
how far we need to hit the ball
is tennis and
in
how
the square
applied
in the Pythagorean theorem.
Tennis.
We also went over velocity and acceleration because that is important. By hitting the ball faster, is it better on serves? It has shown to be better, generating that early point.
Myers. And I will be briefly discussing what is momentum and impulse. And how is physics applied in the sport of tennis.
How to find the momentum and impulse,
we need to
what
discuss
factors,
what is
elasticity impacting in the string's tension. Being able to control the ball better with low tension
physics,
or hitting it sharply and fast without high tension, less reaction time.
What is tennis and how is
and then we've also gone over rotational motion, the types of spins on the ball, and how that can be affected by gravity and air drag. The thing to note is there are many physics principles in every sport. These are the four most popular.
And I will be
we could go on all day
tennis
about
and
many
how
different
is physics
principles.
applied in the sport of tennis.
Understanding that these four principles are good don't understand that they're not the only principles that affect the game of tennis.
So this is serving up physics.
We could go into temperature of the atmosphere, and I will be briefly discussing many other principles.
What is tennis
I just found that these
applied
are the
in the
most
sport of tennis.
important to
First, we
understand,
need to discuss
and
what
they
is
have the
tennis.
bigger impact, the most impact on the game of tennis.
So this is serving
I
up
just
physics.
wanted to briefly explain how physics works in the game of tennis.
And I will be briefly discussing
what you were able to understand how these four principles
in the sport of
have
tennis.
played a big role in the game.
First, we need to
and,
discuss
can
what
impact
is
it.
tennis.
So again, this is serving up physics, and I'm Zach Myers.
This is serving up physics. My name is Zach Myers, and I will be briefly discussing what is tennis and how is physics applied in the sport of tennis.